Welcome back. First official teaching video here. It's going to be big things. Today we're going to talk about the Polygon angle sum theorem. First big guy, chapter 6. We're going to learn how to find the sum of the interior angles of a polygon. We're going to learn how to find the sum of the exterior angles of a polygon. Well, you came in, you had to do a little warm-up. We did some review. Let's go back to that here. So you had to find the basic polygon names. Use your phone, you could use whatever you needed, textbook, things like that. See how many you could just answer on your own. Didn't have to get them all correct, but let's go through the basics here. Three-sided. If you're trying to give me a heart attack, you were answering this one wrong. For a triangle. Now here's where the next one's a little trickier though. What's a four-sided polygon? That's for anything. Some people are going to say, oh, square, rectangle, parallelogram. Well, those are all special types of this specific one, which is a quadrilateral. So those are all special cases, which we're going to learn about in this chapter. This chapter is all about quadrilaterals. So a four-sided figure, all four-sided figures are called quadrilaterals. Five-sided pentagon, six-sided hexagon, seven-sided heptagon. Oh, hexa, hepta. Make sure you study those. You're going to know those because I'm going to definitely put those on a quiz, big time. Then it goes big. We've got our octagon for 8. A lot of you guys know that with the stop sign. Then we get some other trickier ones. We've got 9-sided, we've got our nonagon, 10-sided decagon. There's a couple different names that are also thrown out there with some of these higher ones, like a 12-sided. I forget what the other name is, but we're always going to call it the dodecagon. Now here's the crazy thing. These are your basic names. There are some other names for some of the other ones, but these are the ones we're at least going to be talking about in this class. So up to dodecagon is your big one. But if you have any other numbered sides, say we're talking about 11-sided, what do we call that? Then, you know, if we have some unknown number, what you're just going to write is the number gon. So that's why you have n here. It's the number of sides, n gon. So example here, 17, a 17-sided figure. It doesn't have a special name. It might be crazy high up scientists, but we're not trying to get all crazy into that. 17 gon. Boom. Easy peasy, lemon squeezy. So go ahead and check out those answers real quick. Got your triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon, an n-gon. And our example for that would be a 17-sided figure, which is a 17 gon. Alright? That should be enough time for you. If not, remember, as we go through these notes, anything that might be that you might miss, remember you can go back and watch the video again. You're going to be able to watch it on your phone, watch it on a laptop, whatever you need. So don't get all frustrated. Say, oh my God, I don't get and then make a big fuss here. Just relax. It's okay. We can get through this together. It'll be so much fun. All right. So the polygon angle sum theorem. Do you remember how to find the sum of the measures of the interior angles of a polygon? Have you done it before? I think some have. I think it's been starting to get introduced more and more into middle school time. It was there somewhere. Where n is the number of sides, so n being your number of sides that you have, you can find out what the sum of the angles are by doing n minus 2, number of sides minus 2, times 180. n minus 2 times 180. Take your number of sides, subtract it by 2, multiply 180. Going to be needing your calculators. Doesn't need to be the big fancy ones, doesn't need to be the TI Inspires, but at least something that does multiplication. Yes, your phones do it. No, I'm not going to let you use your phones on the test. Let's not be silly here. But you're still going to need something that's going to be able to multiply and divide. So n minus 2 times 180 tells you the number of sides. So, what's the sum of the angles of a triangle? I mean, we've done it a bunch of times. Think about it. What are the 3 angles of a triangle add up to? We were looking at it. I want to know these 3 angles here. What do these 3 angles add up to? I'm sure some of you are saying, and I'm hoping. Make me a little tight in the chest thinking about it, but it's okay. I'm hoping we got that answer. So how many sides does a triangle have? We know it's 3-sided. So we're going to set it up. 3 minus 2 times 180. Where did that come from? Remember, n minus 2 times 180. N minus 2 times 180. 3 minus 2 times 180. 3 minus 2 is... That's right, you're not here to answer that in the actual video, so 1 times 180. And what's 1 times 180? Oh, great. 180. Yeah, 3 sides. You subtract them by 2, you get 1. 1 times 180. Could be giving you some crazy one. I can tell you, ask you, what's a 100-sided figure? You're going to do 100 minus 2 times 180, right? Now we've got a quadrilateral. What was our quadrilateral again? It was a 4-sided figure. Oh, great job, Tiffany. So, n minus 2 times 180. Put my parentheses in the wrong place. That makes that look like you can just multiply 2 times 180. So I'm going to fix that. Great thing, there's always going to be mistakes. We all make mistakes, including myself. I've now been teaching this for a bunch of years. I'm all old back in the old times, teaching with the dinosaurs and whatnot. But n minus 2 times 180. Thanks for the person in the back that was saying, oh, hello, you're not really old. Thanks, I appreciate that. But n minus 2 times 180, we know quadrilateral is 4-sided. Right? So we're going to plug in. What's 4 minus 2? 4 minus 2 is 2. 2 times 180. And what's 2 times 180? 360. Oh man, it's amazing. You guys are doing such a great job. So the angles of quadrilateral are always going to add up to 360 degrees. 4 angles all end up together, 360. Give you a second to look at that. Soak in, bask in that beautiful work that we have there. No, it looks amazing. Let's move on. Alright, special types of quadrilaterals. We have equilateral, equiangular, and regular. Yeah, they came back again. I mean, remember with the triangles, you had an equilateral triangle, an equiangular triangle. We actually had a regular triangle. Remember when they're equilateral, they're equiangular. It's not going to work out the same with these other shapes. A little different. Equilateral polygon is a polygon with all sides congruent. It means all the sides are congruent. Doesn't mean the angles are, just the sides. Equilateral, all sides congruent. Okay. Oh, Hitler messed up again. He put on his little fancy stuff, little magic. Alright, equiangular polygon is a polygon where all the angles are congruent. All angles. Doesn't mean the sides are, but all the angles, at least, are congruent. Notice this shape here. All of the angles are, but these sides are a lot longer than these sides. It is possible to draw that. Not with a triangle, but with any other polygon. Okay? It can be equilateral and not equiangular. It can be equiangular and not equilateral. Big stuff here. Minds are about to be blown. Equilateral, equiangular. What if it is both? What if it's both of those? What if both of these great things together? It's equilateral, equiangular. They want to go on a date. They get married. They have a baby. Of course, all relationships should take time. Takes a little time here. Boom, we get regular. Regular polygon is both equilateral and equiangular. Am I expecting you to be able to draw this shape perfectly? No, just a nice rough sketch. Nice rough sketch. Doesn't have to be, it's not art class. Remember that. Look at that. Mr. Hiller, this is great stuff. I know. This is so much fun. Having a blast. Alright, we're going to move on. So, there's a corollary. Remember, a corollary is something that, it's like a little side note. It's, I'm giving you these special theorems, these special rules that are true. A corollary is that side note, right? Remember that? It's something that says, hey, well, if I know that that's true, well, what about this special case? There's something else special about it. It's getting more into the problem solving. You're figuring out something. You figure out this great new concept, And then you're going to add on to it. You say, well, I also get this from that, right? So the corollary says that you can find the measures of each interior angle of any regular polygon. It has to be regular here. If it's not regular, this won't work out because all the different sides and angles are different. So what you're going to do is you're going to take n minus 2 times 180, remember that, and we're going to divide it by the number of sides that you have. So n minus 2 times 180 divided by n. The number of sides that you have, you're going to do your normal stuff to find all the exterior angles, then divide by the number of sides that you have. Just divided by n tells you all the interior angles. Wow. This is crazy. Has to be regular though. Means all the sides have to be equal, all the angles have to be equal. You know all the angles are the same, this is going to work out perfectly. We ready to move on? We're ready to move on. Let's do this. I don't know if you can see this. We don't really have 17 pages. I don't know if that's getting in there as a clear enough angle, but trust me, there's not 17 pages. So we got some example problems. We're going back to that quadrilateral. Is there anybody here that knows what an equiangular quadrilateral is? With the angles. If all the angles are the same measurement in that, does anybody just know off the top of their head what that's called? Think about your four-sided figures. 4 sides. And all of them having the same angle measurement. Okay? If you said it, great. If not, no big deal. If nobody knows, because we're just going to go into it. Let the little surprise happen here. I'm going to go blue here, by the way. Big win. We just had it. Alright, so quadrilateral is 4-sided. We know that. It's always good to identify first. Make sure you know you're using the right number of sides. So we got 4-sided. It's 4 minus 2. I'm just making that parenthesis mistake again. 4 minus 2 times 180 divided by 4. If you remember this just being 360, that's fine. Plug 360 and divide by 4. But, in case you don't, 2 times 180 divided by 4. We can go a couple different mathematical steps here, but we're just going to stick with the basics. What's 2 times 180? That's 360. 360 divided by 4. You're saying, well, how can I divide that big number by that small number? Let's think about it without the 0. What's 36 divided by 4? 36 divided by 4 is 9. So 360 divided by 4 is 90 degrees. 90 degrees. 4 sides are all 90. Has to be at least a rectangle. Some people might have said square. Square is part of a rectangle, right? Square is true, but our square is irregular. This is the equiangular quadrilateral. Always has all 4 right angles. What's a hexagon again? What is a hexagon? It's 6-sided. Ah, okay. 6-sided figure. It's going to be fun stuff here. So it means it's parentheses 6 minus 2 times 180 divided by 6. Remember, divided by the number of sides. Silly me, I should have probably wrote this up here on the board for you. Oh, and then I'm writing in green. N minus 2 times 180 divided by n. Here's our formula. Even though I've already set both up. Silly hiller. 6 minus 2 is 4 times 180 divided by 6. Now we've got to figure out, we've got some big math to do here. If you don't have your calculators on, it's okay, because you can just do the math here on the board. Well, you can do it on your paper. I'm going to do it here on the board. So 180 times 4. What's 8 times 4? I'm actually drawing a blank here, 32. 4 times 1 is 4, 4 plus 3 is 7. So 720, man, this board is way off here too. Alright, so then that gives us 720 divided by 6. 72 divided by 6 is what? Let's think about it. You got 60. 60 is at 10, right? Then 66 at 11, and 66, you go 67, 68, 69, 70, 71, 72, it's 12. But we still have that 0, so it'll be 120 degrees. So every interior angle in a regular hexagon is 120 degrees. Give you a minute to soak that beauty in. So beautiful. Gotta love math. You can tell with my monotonous voice how much I love it. God, just all that excitement just pours out of me right now. I want to go whoop. Coming on the other side. Alright. Little curveball for you. Find the measure of angle Y. Oh my God, Hiller, it says today. That's so fancy. I know. That's what I do. First thing we need to think about here is what type of shape do we have here? Let's think about it. Well, let's count. That'll help us think. We got 1, 2, 3, 4, 5 vertices. 5 vertices. Which means that it's a 1, 2, 3, 4, 5-sided figure. 5-sided figure. Pentagon. Oh man, that's great. Pentagon. Even if you don't remember the name, it's not going to make a difference for you actually solving this, technically, but I just want you to know your names. Yeah. So, we have 110, we have 90, we have 120, we have 150. We're missing this little guy right here. Do we need to use the angle sum theorem or the corollary? Are we trying to find what all the angles add up to? Or are we trying to find out what each individual angle is because it's a regular polygon? This is regular? Not regular. Sides aren't equal. The angles aren't equal is really what you can tell right off the bat. You got 110, you got 90, you got 120, you got 150, you're all different angle sizes. So you're not going to be able to tell what the angle measurements are. Sorry if you walk across. So much fun to do it. Throw curveballs at you. So we have 5-sided, so we need to use our Polygon sum theorem. N minus 2 times 180. Not dividing by n, because we don't know or it's not a regular shape. It doesn't have all congruent angles, all congruent sides. So we have n minus 2 times 180. That would be 5 minus 2 times 180. That's 3 times 180. So again, we're going to have to go over here. 180 times 3. 3 times 0 is 3. 8 times 3, 24. 3 times 1 is 3, plus 2 is 5. The angles here have to add up to 540 degrees. Angle T, technically the measure. Angle O. Barely, just missing out fitting it in, is equal to 540 degrees. All 5 of these angles have to add up to 540. We don't know angle Y, so let's just plug in. So angle T is 110, angle O is 90, angle D is 120, angle A is 150, angle Y we don't know, so we're just going to put Y there. It's okay, we're just putting it as a variable. That's equal to 540. Yeah, we have to add all these up. But let's think about this. Make this at least a little easier. What's 110 plus 90? 200. What's 120 plus 150? 270. So we got 200 plus 270, 470. See, that wasn't so bad, right? Wasn't so bad. So you have 470 plus y equals 540. We're almost there. Now what do we have to do? We got to get y by itself. Subtract 470. So if we want to go old school math, 0, 0, we put a 4 here. 14 minus 7 is 7. This cancels that and drop to a 4 because of making that a 14. 15. 4 minus 4 is 0. The measurement of angle y is 70 degrees. Crazy. Crazy. Give you a second to soak all that beauty in. Look at this, 20 minutes. 20 minutes. Alright. Here's our grand finale. I also told you for our objectives for today, we wanted to figure out what the exterior angles were as well. So our exterior angles are going to add up to 360 degrees no matter what the shape is. All the angles add up to 360 degrees. All the exterior angles that are created. And that's these little guys that just pop out. So we'd have all these interior angles, and if we drew a little line on here, and we drew a bunch of these, they would all add up adding up to 360. Give you a chance to write all that fun down. Alright, I'm going to throw a little bit of a curveball at you here. This is a 5-sided shape, right? So we have a pentagon. We have 5 exterior angles. Let's just say that this is regular. If we wanted to find out what each of these interior angles were, we know the interior angles of a regular polygon. We know we would do n minus 2 times 180 divided by n. You hear little kitties coming in, I might be quick. So we would divide by n, right? What about the exterior? If we wanted to find the interior angles, we would add up to 180 and minus 2 times 180 divided by n. So for the exterior, we know the angles add up to 360. So if we want to find it for a regular, you do 360 divided by n. Divide by the number of sides. If you know all the angles are going to add up to 360 and they're all the same, because it's regular, they're all the same, divide 360 by n. Another fun lesson. And now first time in video. Keep it real in the phys field.